Hello everyone, happy to see you here. Welcome back to my channel. Today we have a really interesting question: x squared minus x cubed equal to 36. We need to solve this equation for x. So right now let's start. Of course, you can write your assumption, you can write your solution in the comments below, and then we will check your answer. So I swear it will be really interesting. So first of all, let's write the 36 on the left side. So this is our first step. Let's start with that. So as a result, we have the same beginning: x squared minus x cubed and minus 36 equal to 0. Right now, we have square and we have cube. Right now, let's look closely at the 36. Can we express this 36 as a sum or as a difference as the cube and square? Right now, let's try to think a little bit about it, because this 36, there are a lot of ways how can we express this. For example, we can express this as 20 plus 16, something like that, and a lot of ways. But the best way to express this 36, from my perspective, is 27 plus 9. Okay, let's do it. So 27 plus 9. And a lot of students might be asking, why 27 plus 9? Because 27 right here can be written as 3 cubed, and 9 can be written as 3 square. So right now let's apply. Instead of this 36, let's write 27 plus 9. So let's do it right now. We have x squared minus x cubed, and minus, instead of 36, as I said before, we write 27 plus 9. I just solve this question step by step. I want you to understand this step by step. Right now, let's open parentheses. So as a result, we have x squared minus x cubed minus 27 and minus 9. Of course, we can write this instantly. So from here, we can easily write the next line without this second line, because minus 36 can be written as minus 27 minus 9. But then a lot of students might be confused. Where did we find it? Why do we write this as 27 plus 9? So in that case, I just want to write this step by step. Okay, right now, instead of 27, as I said before, we write 3 cubed. Instead of 9, we write 3 square. So we have x squared minus x cubed minus 3 cubed and minus 3 square equal to 0. And right now, as I said before, we can group. So what do we have? We have x squared and we have 3 squares, so we can group it. We have also x cubed and we have 3 cubed. So we can also group these variables, these elements. So let's start, for example, with the squares. So x squared minus 3 square, this is our first step. So x squared minus 3 square minus 3 square. Okay, we have minus, and right now a sum of cubes, because we have parentheses. So right here we don't have like x cubed minus 3 cubed. We have to write x cubed plus 3 cubed plus 3 cubed. Okay, so I really hope you understand this step. So it is our first part. Right now, let's look closely. What do we have? We have two parentheses. What do we have right here? Difference of squares. What do we have right here? A sum of two cubes. Sounds familiar, yeah? We can easily remember this formula from school. So first of all, we're gonna remember difference of squares. So a squared minus b squared, a squared minus b squared, equal to a minus b, a plus b. This is all known formula. A minus b, a plus b. What about this one? Sum of two cubes. We can also write this formula. We have a cube plus b cube. Yeah, we have a cube plus b cube equal to a plus b. So this is all known formula. If you have problems with it, you can look at your book and remember or learn these formulas. A squared right here minus ab and plus b square. So these are our formulas. Right here we're going to apply difference of cubes, a difference of squares. Right here we're going to apply sum of two cubes. So let's start with it. Let's do it. So I'm going to start right here on the left side. So let's start, for example, with difference of squares, because we have first difference of squares. So we have x minus 3, and x plus 3, x plus 3. This is a difference of squares. So what about the next parenthesis? We have minus, and right now sum of two cubes. We have x plus 3, x plus 3, and in another parenthesis we have x squared minus 3x and plus 9 equal to 0. Really great. Right now, what do we have in common? We have x plus 3 right here, and we have the same x plus 3. So we can easily factor this x plus 3 as a common expression. So let's do it right now. We have x plus 3 x plus 3, and in another parenthesis, what do we have? We have x minus 3 from here, so let's use parentheses, x minus 3 right here, and minus, we still have this complicated expression, so we have x squared minus 3x and plus 9, really great, and parentheses and equal to 0. We can simplify this x plus 3, but we can simplify this big parenthesis. Right now, let's do it. So we have x plus 3 from here, and right now a long uncomplicated expression, x minus 3 without parentheses, x minus 3 without parentheses. Right here we need to change all the signs to the opposite one because we have a negative, minus x squared plus 3x and minus 9 equal to 0. Really great. And the final step, let's simplify, let's reorder it because we prefer a classic order. It looks like a quadratic equation, so that's why we need to write this x squared on the first position. So right here, right now, I hope you understand it. So x plus 3 in the beginning, and right now, let's reorder all of this stuff, or let's, for example, add it. So let's, for example, order all of this stuff. So minus x squared on the first position, minus x squared. What about the next thing? With x, so we have x plus 3x, so plus 4x, and minus 3 minus 9, we have minus 12. Yeah, minus 12 equal to 0. And a final moment, of course, it's not necessary, this is up to you, but we can multiply it by minus 1, because this is not a classic order of signs. We prefer a classic order with x squared. Right here we have minus x squared. Of course, this is up to you. Okay, leave it like that. I really hope you understand what I mean right now. Of course, you can multiply it by minus 1 and you will have a classic order, but no problem. Let's start. Let's continue, okay? So we have parentheses, a product of two parentheses. So a product of two parentheses equal to 0 when first parenthesis is equal to 0, so x plus 3 is equal to 0, or the second parenthesis is equal to 0, minus x squared plus 4x and minus 12 is equal to 0. So it's like our two branches, first branch and a second branch. So we can instantly solve this branch, x plus 3 equal to 0. From here, our x first is equal to minus 3. This is our first branch, and we have our first real number root. This is our first real number root. I hope you understand it. Right now, right here, we're going to apply by minus 1. As I said before, it's not necessary. But if you multiply right here, you have already a great expression. But right now, we're going to multiply it or divide by minus 1. And we have a classic order of signs. X squared minus 4x and plus 12. Okay, and equal to 0. So I hope you understand what I mean. Okay, right now let's continue. We're gonna solve this part, this second branch. This is up to you. I prefer a classic method of coefficients. So from here, a equal to 1, b equal to minus 4, and c equal to 12. And right now let's find, for example, let's solve it for a discriminant. Let's do it. Let's solve it for a discriminant of d equal to b squared minus 4ac, b squared minus 4ac. And let's plug in each of these elements into this spot. So minus 4 squared, minus 4 times a times 1 times c times 12, yeah? So equal to 16 minus 48, yeah, 16 minus 48. And right here we have minus 32. So our discriminant is negative. So it means, yeah, it's less than 0. So it means that in this branch we have two complex roots. In this branch we have two complex roots. So right now let's find all of this root. First of all, we will start with the x second and third, yeah, right here. Because x first is real number, so right now let's continue with x second and third, equal to minus b plus minus square root of discriminant and all over to a. Alright, so let's plug in everything. So from here we have minus 4 plus minus square root of minus 32 and all over 2 times a, 2 times 1. Really great. And equal to minus 4. We have 4 plus minus square root of minus 32. A lot of students might be thinking that we can't evaluate it, we can't simplify it, but 32, okay, let's forget about this minus, but 32, we can express, of course, a times 4, but the best way, 16 times 2. So let's express this, of course, minus 32. So let's start with minus 1 times 16 and times 16 and times 2 and all over 2. Okay, I hope you understand it. And right now let's split it. Let's split this square root. We can write it as 4 plus minus square root of minus 1 times square root of 16 and times square root of 2. all over 2. Right now, square root of 16 equal to 4. This is our imaginary unit, so in our numerator we have 4 plus minus 4i square root of 2 all over 2. And the final step, let's divide our numerator by 2. So we will have like, we can write it like that. Maybe a lot of students don't understand what I mean right now. We have 4 over 2, so we divide it by parts. 4 over 2 and plus minus 4i square root of 2 over 2. So our final answer, right here we have 2 plus minus 2i square root of 2. 2i square root of 2. And of course, right here you can easily say, okay, this is our real part and this is our imaginary part. So overall, we have 3 roots. And let's write all of these roots, for example, right here on the left side. So our answer to this question, so x first equal to minus 3, x first equal to minus 3. And let's group it, let's gather all of this together. X second and third, we have 2 plus minus 2i square root of 2. Okay, really great. So this is our complex roots. This is our real number root. And according to a fundamental theorem of algebra, let's rewrite our question. Let's check, for example, our real number root right here. So let's do a quick check. Let's do a quick proof. So we have x squared minus x cubed equal to 36. So let's plug in right here this x first equal to minus 3. So we have minus 3 square minus 3 cube equal to 36. Okay, let's do it. So minus 3 square equal to 9. Yeah, we have a positive value. But this is our odd power, so we still have negative sign. With this negative, we have positive, so plus 3 to the power 3, we have 27. So yeah, this root is absolutely correct. And x first equal to minus 3 is a correct root to our question. Of course, you can easily check this complex root, but this is not necessary. Every time you have an equation, this is great for you to check our real number root, if it's possible, of course. Right here we have a classic integer with the basic process right here, so we can do this real quick. Okay, so it was my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If we're talking about this question, this is not a hard question. This is a very basic question with different tricks, different things. The first trick, we rewrite this 36 as a sum of a cube, so we can express this 27 as a cube, and this 9 we can express as a square. We group something, have 2 formulas and basic calculations, and in the end, quadratic equation and a linear equation. Moreover, a lot of students might be thinking, because sometimes students find this root, solve this question by inspection. They might be thinking, okay, let's for example check this root, maybe x equal to 1, 2, 3, 4, and they find this root. They solve this for example minus 3 instantly because they find this root by inspection. This is not a good method because you forget about this this complex part. Of course, you can use inspection method to check a question real quick. For example, on your exam, you're sitting and I'm not sure what is the correct root, and you'll like, okay, maybe x1, x equal to 2, x equal to 3. This is a great thing to check a root, but don't forget about another branch, because right here we have also 2 complex root, and this is a full solution to this question because we have a cubic equation. So according to a fundamental theorem of algebra, we have 3 roots in total. In our question, 2 complex, 1 real, but sometimes you have 2 real, 1 complex. It depends on the question. Yeah. So I really hope you understand my thoughts. I really hope you understand what I mean, because every time you have an equation on your exam, every time scan it in terms of fundamental theorem of algebra. For example, the highest power 3, it means 3 roots right here. Even though right here we have x squared, so it means 2 roots. Linear function right here, 1 root. And I really hope you understand this quick trick to scan how many roots you can get from your equation. Yeah, it was my few thoughts about this question. I really hope you understand it. So thank you everyone for your time. Also write a question in the comments below. What do you think about this type of question? Maybe you have your own solution, your own method. It's also really great to exchange information in the comments below, because we have really great community, and I want to say thank you for everything that we are all together right here. We are learning, we studying math, we practice in math, because there are a lot of students, teachers here, so it's really great that we have that community. I'm really proud of you, and yeah, this is a great thing nowadays to learn something. So wish all the best in life, take care of yourself, and have a great day. See you in the next videos.